So today we're going to cover Chapter 1, Section 4A, and today we're going to solve by factoring. So our steps for solving by factoring, we need to get all of the terms to one side, setting the equation equal to 0. Then we're going to factor the equation, any type of the factoring that we've already done. This is what you're going to see. And then you're going to set each term or each one of the parentheses equal to 0 and then solve. Now, your term may be a GCF, and you do also have to set that equal to 0 as well. So let's go ahead and see what we hear. So what we're going to do here first is make sure that it's set equal to 0. It is. And now we can begin factoring. This is the difference of two squares. So I'm going to factor it into x plus 1 and x minus 1. And then the whole thing is still equal to 0. But now what I do is I take each one of the individual parentheses and I'm going to set them equal to 0. And now I've made two little equations that I'm going to solve. So I'll subtract 1 from this one. X equals 1. And x also equals positive 1. Now, when we start to talk about graphing quadratic equations, this is a quadratic equation. It's got an exponent of 2. When we factor quadratic equations, these are actually our x-intercepts. So when we go to graph them, we'll be factoring them to get the x-intercepts, and then we'll be plotting those points. So again, factoring's not going away. We're going to keep doing it over and over again. Everybody good on this one? So this has two solutions. Now, when you're keying in your answers to WebAssign tonight, just read how they want you to put the answers in. Sometimes it'll say, put the smallest answer first. So you would key in the -1 first and then the positive 1. So just make sure you're reading how they want you to enter your answers on WebAssign. The order that you enter them may make a difference. All right, let's try the next one. This is not the difference of two squares. However, what I can do here is factor out a GCF. And my GCF is going to be x. So let me go ahead and factor the GCF out. I'm left with 3x plus 1. And now I set each term equal to 0. So I set the GCF equal to 0. And then I set what's in the parentheses also equal to 0. The first one's already set and solved. It's x equals 0. That is one of my answers. Subtract 1. 3x equals -1. Divide by 3. And x equals -1/3. So I have two answers here. I have x equals 0 and x equals -1/3. Again, if we were graphing this, it would hit the x-axis at 0 and also at -1/3. Let's try the next one. Again, I need to set my equation equal to 0. I'm going to subtract x. And now I'm left with x squared minus x equals 0. Again, another GCF scenario here. So I can divide both of them by x. And I'm left with x minus 1 equals 0. Set each of my terms equal to 0. The GCF equals 0. And then now what's in the parentheses? That one I got to work for. Got to add 1. And x equals positive 1. So I have two answers. X equals 0. X equals positive 1. So sometimes it's as simple as factoring out a GCF. Or it may be a trinomial that we need to factor. We're looking for the factors of a -8, that when I combine those factors, I get a positive 2. And those factors are going to be positive 4 and -2. Because positive 4 times -2 gives me the -8. And then when I FOIL this and do outer and inner, I get the positive 2. My advice to you is when you factor something, quick check this outer and this inner and make sure it is giving you the middle term. So for example, 4x and -8x, and I forgot something. No, sorry, I did that wrong. 4x and negative 2x. And then when I combine them, I get the positive 2x that I need. A lot of you on the test, you had to factor denominator and you didn't FOIL it, so you got the wrong factors. I believe it was something like x squared, I think it was like x squared minus 5x, 6 plus 6. A lot of you said it was x minus 1. I think you said it was x plus 6 and x minus 1. Well, when you FOIL this, you don't get a negative 6. You get a negative 6 and you want a positive 6. So the correct answers for this should have been negative 2 and negative 3. So I can't stress enough that you need to be FOILing this to make sure it is giving you your original problem. So this was just a side note here. This is what I saw in the test, that people made this mistake. It was simple enough. There was only 2 factors of 6, 1 and 6 and 2 and 3, but a lot of you picked 1 and 6 and it should have been 2 and 3. And we'll talk about this in a minute. All right, so back to this one. So just quick, main thing I would do is outer and inner. If you're still not totally confident, do the whole FOIL. So now that I found the 2 factors, x plus 4 equals 0, x minus 2 equals 0, subtract 4, x equals negative 4, and x equals positive 2. And those are my 2 answers. Let's try another one. Get a little bit more challenging with a little bit more challenging of a trinomial. Now again, there's not a whole lot of factors here, so I could guess and test, but let me go ahead and do the factor by grouping because, you know, I think that's sometimes easier. So factor by grouping, you're going to multiply beginning and end. We're looking for factors of negative 30. That will give me negative 1. When the middle term is a 1 or a negative 1, that's a clue to me that my factors are going to be side by side. But let me go ahead and list them all. So I have 1 times negative 30. 2 times negative 15, 3 times negative 10, and then lastly 5 times negative 6, and that's my magic combination. So again, to factor by grouping, rewrite the first term. Replace the middle term with these, and these all have x's because this is a 30x squared. So when I plug them in here, it doesn't matter the order you put them. I'll put the negative 6 first and the positive 5 second. And now I'm going to make my groups. Got a red group, got a blue group. Now you don't have to do the grouping if you're good at guessing and testing. So GCF of red is 2x, and I'm left with x minus 3. GCF of blue is positive 5, and again, x minus 3 remains. Take this, which you have just one of, and then take the 2 GCFs you just divided by, put them together. These are your factors of that trinomial. Now we got to take it that one extra step, set each of these factors equal to 0. So 3x, x minus 3 equals 0, and 2x plus 5 equals 0. Add the 3, x equals 3, subtract the 5, 2x equals negative 5, divide by 2, and x equals negative 5 over 2. I'm okay with you leaving that. If when we get to the quadratic chapter and you're graphing this, you might want to make it a mixed number or a decimal, just so you'll know that you got to put that point at 2.5. But I'm okay right now with you leaving it improper. Let's try the next one. Again, next one is not in the correct form. We need to make the equation equal to 0. So I need to subtract 3, and then I'm left with 2x squared plus 9x plus 4 equals 0. Again, this one's easy enough again to guess and test. Factors of 2 are just 2 and 1. Factors of 4 are either 1 and 4 or 2 and 2. So if you want to guess and test, you can. But let me go ahead and do the factor by grouping. So I'm going to multiply beginning and end. So I'm actually looking for factors of 8x squared. That will give me 9. And that's either 8 and 1 or 2 and 4. And it's going to be 8 and 1. And again, remember those have x's. So rewrite the first term, 2x squared. I'm going to replace this 9x with the two factors I just found. And now I'll make my groups. Red group, blue group. And the blue's not showing up. Let me do green. Green will show up better. Okay, so red, GCF is x, 2x plus 1. Green group, my GCF is 4, 2x plus 1. Take what's in common, which is the 2x plus 1. And then take the two GCFs you divided by. They go together. And now set each of the factors equal to 0. So 2x plus 1 equals 0. X plus 4 equals 0. Subtract 1. 2x equals negative 1. Divide by 2. My first answer is negative 1/2. Over here, subtract the 4. And the other one is x equals negative 4. So my two solutions here. Let's try number 7. Pretty good. Again, we need to set the equation equal to 0. So I need to subtract 3x. 6x squared minus 3x equals 0. I need to factor out a GCF, and my GCF is going to be 3x, because this isn't the difference of two squares. So the only thing I can do here is a GCF. So 2x minus 1 equals 0. Set each of your terms equal to 0. So the GCF first, 3x equals 0, and then the parentheses. Divide by 3, x equals 0, add 1, divide by 2, and my two solutions are x equals 1/2 and x equals 0. Same thing on the next one. I need to make the equation equal to 0 first. So I need to move the 2x over. So I'll subtract it. 8x squared minus 2x equals 0. Not the difference of two squares, so I'm going to factor a GCF. My GCF is 2x. Once I divide, I'm left with 4x minus 1. Again, set each term equal to 0. And now solve. Divide by 2. X equals 0 on the first one. Add 1. Divide by 4. And my second answer is x equals 1/4. So 0 and 1/4. Again, next one, we need to have it equal to 0. I always want to try to keep my x squared term positive. So I'm going to move these two to the other side. So I'm adding 6x and adding 9 to both sides. So my rearranged equation is now x squared plus 6x plus 9 equals 0. Now, if you recognize this, this is a perfect square trinomial, and you could go right into a binomial squared. However, if you didn't recognize it, you could find the factors of 9 that give you 6, and that's going to be 3 and 3. So this is actually x plus 3, x plus 3. Or you could say it's x plus 3 squared. However, all I need to do here is, since it's repeated, you don't need to do it twice. This only has one solution, and x equals negative 3. You don't need to list it twice.
If you did list it twice, like on the test, would it be wrong?
No. Because what's going to happen is when we go to graph these parabolas, this just means that our vertex of our parabola is going to be sitting on the x-axis. And you probably did some basic quadratic graphs in your Algebra 1 class. So you probably saw this before. All right, let's try the next one. Again, perfect square trinomial here. So you can either do it the long way, you could do the factor by grouping, but if you realize that this is a perfect square and this, remember to test it, you square root that, 4x squared, and you get 2x. You square root the 9, you're going to get 3, and then you're going to double it, so you get 6x times 2. If it gives you the middle number, then you know it's a perfect square trinomial. And all you need to do is take the square root of that 4x squared, which was the 2x, take the square root of the 9, and keep the same sign that's in the middle. And that's how you factor the perfect square trinomial using the trick. However, you can do it the long way by finding factors of 36. That'll give you 12, and just do it the other way. Again, this is also represented as 2x plus 3, 2x plus 3. Again, only solve one of them. You don't need to do the work for both because it's the same answer. 2x equals negative 3. Divide by 2. And x equals negative 3 over 2. Now, number 11, if you think about it, it looks just like number 4. The only difference are the signs. Same numbers and letters, but we switched up the signs on it. So factors in negative 8, that'll give me negative 2, and that's going to be x minus 4 and x plus 2. Set each of the factors equal to 0. Add 4. X equals positive 4. And x equals negative 2. So again, always when you factor this thing, I highly recommend you do a quick FOIL on this and then just double check that it did go back because it'll save a lot of answers. Next one. Now again, I want to keep my x squared term positive. You could subtract the 3 and then factor out a negative 1 GCF if you want. Let me just show you how that could work as well. Or it would be probably a lot easier just to move these guys over to this side. But let me show you because you might be thinking, oh, I'd rather move the 3 over. I'm only moving one number. But when you factor these, you want to have a positive x squared term. So I need to factor out a GCF of negative 1. So negative 1, then flip all the signs. And now I can factor what remains. I'm looking for factors of positive 3 that when I combine them will give me a negative 4. So that's going to be x minus 1 and x minus 3. Because to get a positive 3, signs need to be the same. So now, technically you would have to set your GCF equal to 0. However, whenever it's a constant GCF, we don't need to even do that. Because that's nonsense. Negative 1 doesn't equal 0. But these two I do. I'll solve these. Plus 1. First answer is x equals positive 1. And the next answer is x equals positive 3. All right, next one has a fraction. I do not want to have to factor a fraction. So what I'm going to do is I'm going to get rid of the fraction by multiplying everything by the LCD. So I'm going to multiply my entire equation here, all three things, by 8. So I'm going to distribute an 8 here, here, and here. So the first one, it just makes the 1/8 cancel, so I'm left with x squared. And then I'm going to multiply 8 times the 1, and it's negative 8x. But then I have to do 8 times negative 16, and I get negative 128. Honestly, finding the factors of negative 128 are a lot better than trying to factor with fraction. So now I need to figure out what the factors are of 128. So I have 1 and 128, and the signs need to be different. So my bigger factor is going to be negative because that's the sign in the middle. I can divide it by 2, and that's 64. 128 divided by 3 doesn't work. 128 divided by 4 is 32. 5 doesn't work. 128 divided by 6, it's not going to work because it's not divisible by 3. 7 doesn't work. 8 works. And those are my factors. So again, x plus 8 and x minus 16. Set each of the factors equal to 0. Subtract 8. First answer is negative 8, and the second answer is positive 16. And I'm done. And that's it for the factoring, solving by factoring. Now we're going to do solving by square root method. Now, when you go to do the square roots in WebAssign, it's going to ask you for your answer in simplest radical form. And it's also going to ask you for the decimal. So you're going to need a calculator to do the decimal portion, and it can just be a basic 5-function calculator that has a square root on it. So it's going to ask you on WebAssign to enter both answers. On my test and my quiz, it'll only be in simplest radical form. We will not use a calculator. So let's go what the square root method is. So solving equations by square rooting, again, we want this time to get the square term on one side. And then once we square root our answers, we're going to put a plus minus sign in front of the root. So whenever we square root a number, we're going to get both the positive and the negative answer. Generally, what you found in geometry, whenever we solve things using a square root, like Pythagorean theorem, we would never keep the negative answer because we would never want a negative side length. But here in Algebra 2, we keep both the positive and the negative answers. So let's go ahead and try our first example. So the first one is x squared equals 15. My squared term is isolated. It's on one side of the equal sign. So now all I have to do is square root both sides. So let me go ahead and just rewrite it. I'm going to square root the left and the right side. I got to keep things balanced. Square rooting a square makes the radical disappear and the square. So now I'm left with x equals, and then it's just plus and minus the square root of 15. Because if you think about it, if you do the factor tree, it's just 3 times 5. No pairs, so that's your final answer. Next one. So in WebAssign, it's going to ask you to enter probably positive square root 15, negative square root 15, and then it's going to ask you to evaluate and find the square root of 15. I think it's to do decimal places. So this is going to be 3.87, and this will be negative 3.87. So in WebAssign, just have a handy-dandy little basic calculator. You can use your phone. You can use your iPad calculator. On the test, I will expect you to just tell me the answer this way. Now, this plus minus sign that's in front, if you've never seen it before, it's just a shortcut version of instead of writing it out as positive square root 15 and then negative, they just put the plus minus to take care of both at the same time. Let's try the next one. My square term is already isolated, so all I have to do is square root both sides. So I'm going to square root the left, square root the right. X is equal to plus and minus the square root of 48. 48, however, I can put into simplest radical form. I can break 48 down. Now, if you're good and realize that it's just 16 times 3, and 16 is the perfect square, then it's just 4 radical 3. And that would be your answer, plus and minus 4 radical 3. If you didn't catch that, and you'd rather keep breaking it down till it's prime, let's say you did 6 times 8, because you didn't know 16 went in there, then you're going to keep breaking it down till you get to prime numbers. I got a prime here, a prime here. 4 needs to go to 2 and 2. Look for pairs. Got a pair of 2's here. And then this one pairs with this one. So a 2 comes out of that one. A 2 comes out of this one. And the 3 doesn't have a pair. Multiply everything that came back out. And there's the same answer I got when I just did 16 times 3. And again, on WebAssign, it's probably going to have you enter it as negative 4 root 3. And then it's going to make you figure out what that is. And that's approximately 6.93 negative. And then it'll enter as positive and then positive. So just have a basic calculator for the homework tonight. Again, on the quiz on Thursday, you're going to tell me this is the final answer. You will not use a calculator. Try another one. Skip one. Yes, I did. Skip 2. Okay, so again, what we need to do here is we need to realize that my squared term is isolated. So I just have to square root both sides. So I square root this, I square root this. This becomes 4x plus 1. And this becomes plus and minus the square root of 20. Now, what you probably should do is break down the 20 first. This could be 2 and 10, 4 and 5. I'll do 4 and 5. And then if you realize 4 is a perfect square, just square root it. So 4x plus 1 equals plus and minus 2 square root 5. Now, we need to get x by itself. So I need to subtract 1. 4x is equal to negative 1 plus or minus 2 square root 5. And now I have to divide by 4. So x equals negative 1 plus or minus 2 square root 5 over 4. Now, do not be tempted to try to simplify this. The only way you can reduce is if this 4 would also be able to simplify with the 1. So I would leave it just like that. WebAssign may make you separate it. This plus minus means negative 1 plus 2 square root 5 divide by 4, and then negative 1 minus 2 square root 5 divide by 4. So this first plus sign up top here is for this one, and then the minus sign here is for that one. So it actually is 2 answers here that x equals. Try another one. Again, isolate the squared term. So I'm going to add 43 to both sides. X squared equals positive 43. Square root both sides. And x is equal to plus and minus the square root of 43. We can't simplify that, so we just leave it alone. And again, WebAssign's probably going to make you write it as negative 43 square root and then positive 43, and then give the decimal for this to 2 decimal places. So square root of 43 is 6.557, so 6.56, and then positive 6.56. Couple more examples. Again, I want to isolate the square term. I can't have a coefficient in front, so I need to divide both sides by 9 first. X squared is equal to 4. Now I can square root both sides. And x is equal to plus and minus 2. Next one, isolate that square. So divide both sides by 25. X squared is equal to 37 over 25. Square root both sides. So now I'm left with x is equal to plus and minus the square root of 37 over 25. I can't leave a radical in the bottom, but luckily for me, it's actually a perfect square. Now, if you'd rather, think of this as square root 37 over square root 25, and then you simplify it. Plus and minus square root of 37 over 5. Can't leave that radical in the bottom. If it wasn't a perfect square, we would have to rationalize. Let's try number 20. Again, I'm going to do the square root method. I'm going to square root both sides. So x minus 5 squared equals 25. Square root the left, square root the right. X minus 5 equals, and then, now this one, be careful. It becomes plus and minus 5. When I move the 5 over, I now have x is equal to 5 plus or minus 5. This one, you got to do the math. When all the radicals disappear, you're going to turn it into two problems. I'm going to first do x is equal to 5 plus 5, and then x is equal to 5 minus 5. So first you'll do it with the plus sign, and then you'll do the problem with the minus sign. So this answer is x equals 10 and x equals 0. So when the radical disappears, you actually have to do the math there. Do one as an addition, one as a subtraction. Number 21. Again, we're going to square root both sides because the square term is already isolated. Square root, x plus 9 comes out. And then I'm left with plus or minus the square root of 24. I need to break that 24 down. There's a perfect square hiding in there. 4 and 6. Now, if you want to go ahead and go all the way down to prime, look for your pairs. I got a pair of 2's, so a 2 comes out. No pairs here, multiply them back. So 24 is plus or minus 2 radical 6. And now I need to isolate x, so I subtract 9. And final answer is x is equal to negative 9 plus or minus 2 radical 6. 2 more examples and I'm done. The last one's a little different, so make sure you're watching what I do with that one. Everybody good on 21? 2. Again, square root both sides. 4x plus 7 squared, and then 44. Square root it, square root it. 4x plus 7 is equal to plus and minus the square root of 44. When I factor this, it's 4 times 11. 4 is a perfect square, so 2 radical 11. So plus and minus 2 square root of 11. Subtract the 7. 4x, yes, Bradley? Yes. And then now divide by 4. The last example is a little different. Negative 7 plus or minus 2 radical 11 over 4. Nothing simplifies here. Again, don't be tempted to think that you could simplify this. The 4 would also need to simplify with the 7. All right, next. Last one. We need to FOIL both sides because your first step was to isolate the square term. I can't isolate it here. So I actually have to FOIL this. So this is really x plus 5 times x plus 5, and then x plus 4 times x plus 4. When I FOIL this, I get x squared plus 10x plus 25 equals x squared plus 8x plus 16. I skipped the outer and the inner. I already combined them. Now I need to start grouping my like terms. So if I try to move my x squareds together, they're going to cancel on both sides. So 10x plus 25, 8x plus 16, move the 8x, 2x plus 25 equals 16, minus 25, 2x equals negative 9, divide by 2, and x equals negative 9 over 2. And you're done. So that is it for section 1.4a. You have the WebAssign homework. We have a quiz on Thursday on this. Tomorrow we are covering 1.4b, which is going to be completing the square.